third session, we're going to look at Woff-Kishner reduction, and we'll understand it better once we do the mechanism. We'll understand also the reagents which are used in this Woff-Kishner reduction, and we'll know how to convert a certain aldehyde or ketones into alkanes. So let's get into it. So we're doing Woff-Kishner. Woff-Kishner reduction. Okay, so let's look at this kind of reduction. One thing we must understand are the reagents which are used in this type of reduction. So the reagents which are used are, we use Hydrazine, which is just this type of a reagent. We can also use potassium hydroxide. Then we also use hydrochloric acid, and we can say heat. Okay, so these are basically the reagents which are used when dealing with Woff-Kishner reduction. So let's look at the mechanism. Let's say you have this group here. Let's say you've been given this kind of equation with a ketone. Okay, so like that. Then we have the reagent, which are these. Then other than that, we have this potassium hydroxide, or we can have something like water, and also let's say we have reflux. Okay, so this is what we have in this reaction. So now and we can have water. Okay, so let's do the reaction mechanism. Alright, so when I have this, okay, so this is what we have. Then when that reacts, when nitrogen reacts, So there is a reaction between this and this can happen in the presence of water. So what it's going to form, okay. So two nitrogens are attached. Then we have that. So the first thing is that this will attach where there is this carbonyl group, and we explained in the other tutorial where we are dealing with this type of reaction. So we explained the step which take place here. Alright, so if you want to understand it better, you can refer to our video about this same kind of reaction, or now this is attacked by this type of compound. Okay, then once this happens, we can use a hydroxyl from water. We can use this hydroxyl to grab one hydrogen there. When it grabs one hydrogen, that bond will be broken. Then taking the electrons back. Okay. So this is what is going to form. So we're going to form this kind of an intermediate. So you have this. Okay, with one hydrogen now, cause one has been deprotonated, and since it formed, this bond was broken, taking the electrons to nitrogen, so this nitrogen should be negatively charged. Now let's see what happens next. So the next thing that is going to happen here, I can just do some kind of resonance. So I can do this. So I can say we have a carbon layer. So I can perform resonance. This nitrogen has some electrons, so it can form a bond here. Okay, so we can have a nitrogen layer with a bond. Then we have a hydrogen like that. Okay, so we shouldn't forget that there is this group like that. Okay, then after we have that, let me get rid of this. So the next thing I can do here is now to react with the base which I have. So I'll get this. I can get a base. I can get a base, for example, I can get a hydroxyl. So what this my hydroxyl is going to do is to grab this hydrogen here. Then once it grabs this hydrogen, so it is going to take the electrons to this nitrogen. So this is what I'm going to have. So it's going to be in this manner, like that. Then we know we have a nitrogen there bonded to another nitrogen, like that. And since when this bond was broken, it took the electrons to this nitrogen, so it will be negative, like that. Okay, then so there's a double bond here. Then this nitrogen still have some lone pairs, so it can take those lone pairs there, forming a bond. So this is what we are going to have. Okay, so I can get rid of this. Okay, so this is what I'm going to have. We're going to have this structure. Okay, so we can have that structure there. Then so here we have a nitrogen. There we have a nitrogen. Then because these lone pairs are forming a triple bond there, then this is the nitrogen we have here. So this nitrogen now is ready to leave. So this nitrogen will leave. Of course, we know that at this carbon here, since carbon is bonded to 4 things, the other group we have is just nitrogen. So this now nitrogen will leave. So I'll just show it here. Nitrogen has left. Then once it leaves, we're going to have a carbanion. So we're going to have a group like that. So this is the group we are going to have. Of course, there is a hydrogen there. So this is a carbanion which is formed at that point. Then the next thing we are going to do here is just the protonation. So we'll get our water. We'll get our water and protonate this carbanion. So this carbanion will attract a hydrogen. Then we're going to form now this product. So now we have a hydrogen here. So we have now two hydrogen. There's one hydrogen which was initially there, with now this hydrogen which has been formed. Then we have that. So we've now formed our product, which is this one with the alkanes, and the byproduct will be the nitrogen which left at that stage. So this is now the product in this type of reaction, which is known as Woff-Kishner. So this is how you form a product using Woff-Kishner mechanism. Thank you for watching. Don't forget to subscribe, like and share. Then for more tutorial videos, study materials and past papers for the courses which are listed here, you can simply call or WhatsApp this number shown there, or simply email using this email address to reach out for subscription. Thank you so much. Have a great day.